Jupiter, the king of our solar system, reigns supreme with its swirling clouds and giant storms. It's a bustling hub of activity, orbited by over 80 moons. These moons are locked in an intricate dance around their massive parent, each with its own story to tell. They tug and pull on Jupiter, shaping its gravitational field and influencing its atmosphere. Among these fascinating worlds is a small, enigmatic moon named Thelxinoe. Discovered relatively recently, Thelxinoe is a tiny world, barely a speck of dust compared to its larger siblings. Yet, despite its diminutive size, Thelxinoe holds clues to the formation and evolution of the Jovian system. Join us as we journey to this distant world and unravel the mysteries of Jupiter's enigmatic moon, Thelxinoe. Imagine a royal court, bustling with activity, courtiers and advisors circling a powerful monarch. That's a bit like Jupiter and its moons. This gas giant, with its swirling storms and immense gravitational pull, holds sway over a diverse collection of celestial bodies. There are the Galilean moons, Io, Europa, Ganymede, and Callisto giants in their own right, easily visible through even a small telescope. Then there are the smaller, fainter moons, some irregularly shaped, others trapped in resonant orbits. Among this diverse cast of characters, Thelxinoe stands out. This tiny moon, discovered in the 21st century, is a relative newcomer to our understanding of the Jovian system. Thelxinoe's discovery added another piece to the puzzle, helping us understand the complex dynamics of Jupiter and its many moons. In the annals of astronomy, there's a certain allure to the unknown. Thelxinoe, with its diminutive size and distant orbit, is no exception. This small moon, like countless others scattered throughout our solar system, reminds us that our exploration of the cosmos is far from over. Every new discovery challenges our preconceived notions and pushes the boundaries of our scientific understanding. By studying Thelxinoe, we gain a deeper understanding of the history of our own cosmic neighborhood. The mysteries surrounding Thelxinoe beckon us to explore further, to develop new technologies, and to send robotic emissaries to these distant worlds. The 21st century dawned with the promise of new discoveries in space exploration. In 2003, a team of astronomers led by Scott S. Shepard at the University of Hawaii made an exciting discovery. Using the Subaru telescope atop Mauna Kea, they detected a faint object moving against the backdrop of stars. This object, they soon realized, was a previously unknown moon orbiting Jupiter. The discovery of this new moon, initially designated as S2003J2, caused a stir in the astronomical community. This tiny moon, barely a few kilometers across, was a far cry from the gas giant it orbited. Yet its discovery added another piece to the complex puzzle of the Jovian system, raising new questions about its formation and evolution. In the world of astronomy, the process of discovering a new celestial object is only the first step. The newly discovered moon of Jupiter, S2003J2, was no exception. The name Thelxinoe was chosen, honoring one of the Muses, the daughters of Zeus renowned as the personification of inspiration for art and science. Thelxinoe specifically was associated with charm and allure, fitting for a moon that had remained hidden for so long. With its official designation as Jupiter Helsed and its mythological name, Thelxinoe took its place among the ranks of Jupiter's many moons. Thelxinoe, true to its name, has become a source of fascination and inspiration for astronomers. Scientists believe that Thelxinoe, along with other members of the Ananke group, are likely captured asteroids. These asteroids, remnants from the early solar system, were drawn in by Jupiter's immense gravity, becoming trapped in its orbit. Thelxinoe's retrograde orbit, moving in the opposite direction of Jupiter's rotation, adds another layer of intrigue. By studying the orbits of these irregular moons, astronomers can piece together the history of the Jovian system and gain a better understanding of the dynamics that shaped our cosmic neighborhood. Thelxinoe, like many of Jupiter's outer moons, is a small, faint world. It measures just 2 kilometers across, which is less than the length of Central Park in New York City. Despite its size, Thelxinoe is a full-fledged member of the Jovian system, bound to Jupiter by gravity. Its small size means it has very weak gravity of its own. Astronomers classify Thelxinoe as an irregular moon. This means it doesn't have a nice round shape like Earth's moon. Learning about such small and distant objects is a testament to the power of modern astronomy. Gazing across the vast expanse of space, we can only imagine what the surface of Thelxinoe might look like. Based on its size and composition, scientists believe it's a dark, rocky world. The surface is likely covered in craters, the scars of countless impacts from asteroids and comets over billions of years. Unlike some of Jupiter's larger moons, which have atmospheres or even potential subsurface oceans, Thelxinoe is probably a very quiet place. With no atmosphere to speak of, there would be no wind, no rain, and no sound. The darkness of space would be broken only by the distant glow of the sun and the reflected light from Jupiter. Thelxinoe is quite far from Jupiter, much farther out than the more famous Galilean moons. In fact, it takes Thelxinoe about 2 Earth years to complete one orbit around the gas giant. That means a year on Thelxinoe is twice as long as a year on Earth. Instead, it follows a highly elliptical path, swinging close to Jupiter at one point in its orbit and then traveling far out before looping back again. What's even more peculiar is that Thelxinoe's orbit is retrograde. Astronomers believe that Thelxinoe's unusual orbit suggests it wasn't always a moon of Jupiter. Thelxinoe's orbit isn't random. It's part of a group of moons known as the Ananke group, all of which share similar retrograde orbits around Jupiter. These moons are like a cosmic family, bound together by their shared history and their gravitational dance around the king of planets. Astronomers study these orbital resonances to learn about the history of the Jovian system. By understanding how these moons interact gravitationally, we can piece together clues about how they formed and how they've evolved over billions of years. Thelxinoe's story, though seemingly insignificant on a cosmic scale, is a reminder that even the smallest objects in our solar system play a role in the grand symphony of gravity and motion. Imagine Jupiter as the head of a large, diverse family, and its moons as its children. Each moon has its own personality, its own story to tell. Some, like the Galilean moons, are large and well-known, their features clearly visible even from Earth with a good telescope. Others, like Thelxinoe, are smaller, fainter, and more mysterious, their stories still waiting to be fully understood. There's Io, the volcanic moon, constantly erupting with fiery plumes of sulfur. Europa, with its icy surface hiding a potential ocean of liquid water, sparks the imagination with the possibility of life beyond Earth. Ganymede, the largest moon in our solar system, even bigger than the planet Mercury, boasts its own magnetic field. Thelxinoe, in the company of Jupiter's larger moons, is like a tiny pebble next to giant boulders. While the Galilean moons are worlds unto themselves, some with atmospheres and internal oceans, Thelxinoe is a small, airless, and likely inactive world. Consider Europa, a moon about the size of Earth's moon, its surface a mosaic of ice flows, crisscrossed by long cracks and ridges. Scientists believe that beneath this icy shell lies an ocean of liquid water, perhaps twice the volume of all the oceans on Earth combined. Thelxinoe, in stark contrast, is a barren, rocky world. Despite their differences in size, composition, and potential for harboring life, Thelxinoe and the Galilean moons share a common history. They are all bound to Jupiter by gravity, their destinies intertwined with this giant planet. While the Galilean moons likely formed from the disk of material that surrounded Jupiter in its early years, Thelxinoe and its fellow irregular moons are thought to be captured objects. These asteroids or comets, wandering through the early solar system, were ensnared by Jupiter's powerful gravity, their paths forever altered. By studying the composition of these captured moons, scientists can glean insights into the building blocks of the early solar system. In the grand tapestry of the cosmos, it's easy to overlook the smallest, faintest objects. But Thelxinoe, despite its diminutive size and seemingly insignificant presence, reminds us that every object in space has a story to tell, a role to play in the intricate web of cosmic interactions. Its discovery expanded our understanding of the Jovian system, adding to the diversity of objects orbiting this giant planet. Thelxinoe's story is a testament to the power of curiosity and the importance of continuing to explore our universe. The smallest moons, like the faintest stars, can illuminate our understanding of the universe and spark our imagination with the endless possibilities that lie hidden in the vastness of space. Jupiter's system is like a giant scientific laboratory. With its massive size and powerful gravity, Jupiter holds sway over a diverse collection of moons, each interacting with the planet and with each other in complex ways. Studying these interactions helps us understand the fundamental laws of physics that govern our universe. Thelxinoe, despite its small size, plays a role in this grand celestial dance. Its gravity, though weak, tugs on Jupiter and the other moons, contributing to the intricate web of gravitational forces that shape the Jovian system. Imagine the Jovian system as a giant clock, with each moon like a gear, its movements precisely timed and interconnected. Thelxinoe, in this analogy, is a small but crucial gear, its presence influencing the rhythm of the entire system. By studying the orbits of Thelxinoe and other irregular moons, astronomers can model the evolution of the Jovian system over time. These models help us understand how the system formed, how it's changed over billions of years, and what its fate might be in the distant future. Thelxinoe's retrograde orbit, moving in the opposite direction of Jupiter's rotation, is a clue to its past. This unusual orbital characteristic suggests that Thelxinoe wasn't originally a moon of Jupiter, but rather an object captured from elsewhere in the early solar system. Imagine the early solar system as a chaotic billiards table, with planets and smaller objects colliding and scattering. Jupiter, with its immense gravity, acted as a cosmic vacuum cleaner, sweeping up many of these smaller objects. Some of these captured objects, like Thelxinoe, were trapped in retrograde orbits, their paths forever altered by their encounter with Jupiter's powerful gravitational pull. By studying these captured objects, we can learn about the conditions in the early solar system, the types of objects that were present, and the processes that led to the formation of planetary systems. Thelxinoe's orbit, though seemingly insignificant on its own, contributes to the overall gravitational balance of the Jovian system. Its presence, along with the other irregular moons, helps to stabilize the orbits of the larger Galilean moons, ensuring the long-term stability of the entire system. Section 3. A window to the past. Thelxinoe, like a time capsule from the early solar system, holds clues to the conditions that existed billions of years ago. Its composition, though not yet precisely determined, is likely similar to that of asteroids, the building blocks of planets. By studying the light reflected from Thelxinoe's surface, astronomers can infer its composition, identifying the minerals and ices that make up this distant world. These observations provide valuable insights into the materials that were present in the region of the solar system where Jupiter formed. Thelxinoe's dark surface suggests that it's rich in carbon-based compounds, the building blocks of life, While Thelxinoe itself is far too small and cold to support life as we know it, its composition provides clues about the prebiotic chemistry that may have existed in the early solar system, potentially setting the stage for the emergence of life on Earth and perhaps elsewhere. Thelxinoe's story is a reminder that even the smallest, most distant objects in our solar system can hold profound secrets about our cosmic origins. Section 4. Thelxinoe's Tale, a Universal Story. Thelxinoe's story has universal implications. Many exoplanetary systems have moons similar to Thelxinoe. Studying Thelxinoe helps us understand distant moon systems. We apply our knowledge of orbital dynamics and compositions. Thelxinoe's tale reminds us of the universe's diversity. Each celestial body has its own story to tell. Studying our cosmic backyard helps us explore the universe. Thelxinoe teaches us about our solar system's history and the fundamental laws that govern our universe. Section 1. Distant Shores, Future Explorers. Today, Thelxinoe is a distant point of light, visible only through powerful telescopes. Tomorrow, who knows what wonders we might uncover on this enigmatic moon. As technology advances, exploring the outer reaches of our solar system becomes possible. Imagine a future mission to Thelxinoe, a robotic explorer dispatched to unravel its secrets. Equipped with advanced cameras and spectrometers, this mission could reveal the moon's surface in detail. We could map its craters and analyze its composition. Such a mission wouldn't just be about Thelxinoe. It would provide valuable data about the formation of the Jovian system. The data gathered would help refine our understanding of planetary formation. Thelxinoe, once a mere speck of light, would become a new world, its secrets revealed. Section 2. Tools for the Unknown, Unveiling Thelxinoe's Secrets. Exploring Thelxinoe presents unique challenges. Traditional propulsion systems would take years to reach it. New technologies could revolutionize space travel. Solar sails harness the sun's photons for propulsion. Like sailboats, they ride the sun's energy. Ion propulsion uses charged particles for thrust. Ion engines can operate for years, gradually accelerating. In orbit, a spacecraft could study Thelxinoe's surface. High-resolution cameras capture its craters. Spectrometers reveal its composition and minerals. Section 3. Thelxinoe Awaits, a Universe of Mysteries Beckons. Thelxinoe, though just one small moon among many, represents the vast potential for future exploration in our solar system. As we continue to develop new technologies and expand our reach into space, countless worlds await our discovery. Beyond the familiar planets and moons lie countless mysteries, waiting to be unraveled. There are dwarf planets in the Kuiper Belt, icy bodies in the Oort cloud, and perhaps even undiscovered planets lurking in the outer reaches of our solar system. Each of these objects holds clues to the formation and evolution of our cosmic neighborhood, and each represents an opportunity to expand our understanding of the universe and our place within it. The exploration of Thelxinoe, though seemingly insignificant on a cosmic scale, is a step towards unlocking these secrets. By studying the smallest, most distant objects, we gain a deeper appreciation for the interconnectedness of our universe and the profound beauty of the natural world, both here on Earth and beyond. Section 1. Thelxinoe's Whisper. Thelxinoe, a tiny moon in Jupiter's vast court, whispers secrets of the cosmos. Its discovery reminds us that our solar system is still a place of wonder, full of hidden treasures waiting to be found. Though small and distant, Thelxinoe is a window into the early solar system, its composition and orbit holding clues to the processes that shaped our cosmic neighborhood. We've learned that Thelxinoe is a captured asteroid, a relic from the early solar system that got caught in Jupiter's gravitational embrace. Its retrograde orbit, a celestial dance in reverse, tells a story of chaotic encounters and gravitational capture. Though we've never visited Thelxinoe, we can imagine its dark cratered surface, a testament to billions of years of cosmic bombardment. Thelxinoe's story is a reminder that even the smallest objects in our universe have a tale to tell. Its existence challenges us to look beyond the familiar, to explore the unknown, and to unravel the mysteries that lie hidden in the depths of space. Section 2. Our cosmic journey continues. The exploration of Thelxinoe is just one step in our quest to understand the universe. New technologies push the boundaries of space exploration, leading to groundbreaking discoveries. Missions like Juno revolutionize our understanding of Jupiter. One day, we may study Thelxinoe up close. Humans may venture to Jupiter's moons, exploring these alien worlds firsthand. The possibilities are as limitless as the universe. Thelxinoe invites us on a journey of discovery for generations to come. Our exploration of the cosmos is a testament to human curiosity.